The physical layer is the foundation of the OSI model, responsible for the physical connection between devices. It deals with the basic hardware transmission technologies of a network, ensuring that raw bits, ones and zeros, are transmitted from one node to another. This layer focuses on how data moves across physical mediums, such as cables, fiber optics, or wireless signals. At its core, the physical layer handles electrical signals, voltage levels, and data rates. These elements are essential to translating digital data into the physical signals that travel across the network. For example, when we use an Ethernet cable, the physical layer defines how the bits travel over that wire. This layer defines how data is transmitted across the network, either in simplex, one-way, half-duplex, both ways but one at a time, or full duplex, both ways simultaneously modes. It ensures that the transmitting and receiving devices are synchronized at the bit level. This synchronization is critical to prevent data from being lost during transmission. The physical layer defines how data is encoded for transmission. This encoding process converts binary data into physical signals. Different encoding schemes are used based on the medium, whether it's electrical pulses over copper cables or light pulses in fiber optics. This layer defines how devices are physically arranged and connected within the network. Common topologies include star, ring, and bus configurations, which influence the network's performance and fault tolerance. It manages the type of physical connection, whether it's copper wires, fiber optic cables, or wireless transmissions. Each medium has its own characteristics, such as bandwidth capacity and susceptibility to interference. In wired networks, the most common example of the physical layer is an Ethernet cable, which physically connects devices like computers, routers, or switches. The physical layer ensures that data can travel through this cable in the form of electrical signals. In wireless networks, the physical layer governs how devices like Wi-Fi routers and mobile phones communicate using radio frequencies. Here, it manages how radio waves transmit data over the air. Even in advanced networking technologies like fiber optics, the physical layer plays a crucial role. It manages the transmission of data through light signals, which can travel much faster and over longer distances than electrical signals. The physical layer might seem simple, but it's the backbone of all network communication. Without it, the upper layers of the OSI model, such as the data link, network, or transport layers, cannot function. Any issues at the physical layer, such as a damaged cable or poor signal strength, can disrupt the entire network. That's why network engineers often begin troubleshooting with this layer, checking cables, connections, and devices to ensure data can flow smoothly.